want to welcome you guys. Thank you very much for coming. We're going to be talking about autonomous operations and the best practices thereof. My name is Mark Sengupta. I'm a research director here at ARC, and I want to share a little bit about what we're seeing in the autonomous operations area. Little housekeeping here. Please silence your phone. Please also provide feedback after the session. You can do that through the app. There's a little star next to the session. Click on that, answer a few questions. Of course, it'll be perfect because it's mine. And then also be sure to check your app for updates as you go. This is the last session for today, so we stand between you and SeaWorld. Does everybody know where the SeaWorld buses will be?
In the parking lot.
Well, that's close. So you know where we've been eating and stuff. There's a portico there. They'll pick you up there, right? Well, let's talk about that. So how many people came here using Lyft or something of that nature? Okay, quite a few. Quite a few. How many of you would get into an autonomous car with no steering wheel? 2 people. All right. Right in. So what's the difference between that, hiring a driver and sitting in the back seat? Right? So I would contend to you that it's trust. It comes down to trust. And when we talk about autonomous operations, trust was a little harder to come by before COVID, right? But anyway, some of the industry trends and challenges that we are seeing that people companies are trying to deal with, there's a boatload of them, right? And you know, some of these things center around trust. You've got cyber attacks. You've got aging assets, which may or may not be trustworthy. You've got an aging workforce. They may not be here tomorrow because it's retirement time, right? We're still retiring 10,000 workers a day. They're aging out of the workforce. We are now aging people out of the workforce from Gen X. That's kind of interesting because that's my generation. And I'm like, why aren't I aging out? But anyway, but you've got other things around cost, agility. Obviously, the supply chain's thrown some stuff at us that we've had to deal with. Things around safety. You got sustainability pressures, ESG, depending on how you want to define that. We've also done a survey here recently, and you look at what the top responses were, and we're looking at excellence in delivery quality products and services, sustainability, a bunch in operational excellences. You got leveraging data to optimize, and you've got talent, change management, collaboration, innovation, culture. Where does it look like autonomy and autonomous operations would fit? Probably all of them, right? Your biggest goals in digital transformation, automation. Take a look at some of the other things that you get from quote unquote digital transformation. Which of these correlate with automation? I would posit that all of them are fed by automation. And so where's that put you guys? How does autonomous operations help? You know, I've got reduced complexity in the operating process. You want to get rid of that human error. Improve reliability and adaptability, consistency, efficiency, reduce the workload. You want to take the mundane out of the work. Because one of the things we're having trouble with is attracting young workers with the skill sets you need, and now those skill sets are the same skill sets that Google wants, in Microsoft, And you're competing with them in their game rooms, although I think they got rid of some of those. But you know what I'm talking about. You want to make it safer. And you want to institutionalize operating discipline. You want to make that stay with the company, not go with the retirement, or even if they change jobs. And autonomous operations addresses all of that to some extent. Now we have a model. Everybody's got a model at this point. You can get more granular in it or not. But you'll see you've got totally manual going up to totally autonomous and things in between. I'm not going to belabor it because like I said, everybody's got something. But what I did want to point out on the slide is that most people are and they're not 100% in any of these. They kind of bounce around between these. Sometimes they'll have a piece that's over here within the same operating fence, right? Okay, so some of the hindrances, obviously cost. Sometimes we find that some users don't have the infrastructure needed to go forward, so they've got to address that. And when you think about addressing infrastructure, you can't talk about ROI at that point. The ROI is in the actual use case that you haven't built yet because you haven't got the infrastructure. So that's a challenge. There's a challenge with some of the talent. And what we're seeing is a lot of companies are going outside, contracting, finding a supplier of some sort or a system integrator who's able to supply that talent that they can't get. One of the other challenges that some people have are labor contracts and there's labor relations. Unions are notorious for fighting anything that says automation because they equate it with replacing a person. The reality is that automation isn't replacing people. People who automate are replacing people, right? And that's been proven over time. Automation actually increases the type and level of work and the number of people that we use to support it. Okay, some current regulations, trusted technology we talked about. I like to highlight this. Some maintenance practices are from the 80s. And if you're going to automate your processes, you're going to have to be more proactive. Because once you start automating and something fails, your automation stops, right? The excessive IT costs has come up before. And there's also, since coming out of COVID, we have this return to normal mindset. Now, let's face it, we are all shaking hands at the conference here. And we all say it's glad to be back to normal. One of the things that COVID did is it kind of pushed us toward automating. And some people are, I think the want and the desire to really make those changes for automation kind of slowed down, right? So we have to be careful of that. Okay, and with that, I'm going to ask Keith DeSherry to come up.
All right, first just an introduction. Keith DeSherry with BASF Corporation. My fan club is sitting right down here in the second two rows. Thank you, Mike, Glenn. Been with the company for 32 plus years now. Started when I was 8 years old, just in case any of y'all question how young I look. So I knew that was in a bunch of y'all minds. So I'm gonna start off by telling you just a little bit of a story. So most of you probably flew here, for the most part. Well, we're changing something on your flight back home, okay? We're changing, and it's going to be completely autonomous planes. You've got autonomous airlines. So you will be boarding flights that no longer have pilots on it. You will be boarding flights that basically have a work crew on it and yourself. And we're going to fly you. If something starts to happen, air traffic control tower is going to make a remote access to the plane and change the direction, get you out of turbulence. And God forbid if something really starts to go wrong with autopilot, which has never happened in the history of the airline industry, they will take over control, just like running a video game. They'll do that from air traffic control, and they'll just pass you on from tower to tower if you're flying across the United States. So basically, you got really nothing to worry about on your flight home. I didn't know if y'all knew Orlando was switching to that when you flew here, but that is exactly what you're going to be having on the way back. So I think your question about Lyft and Uber, I think, you don't have a choice. You got to get in the empty airplane. No pilot's going to be there. So the reason I bring this up is actually for 2 points about how to look at autonomous plants, okay? The whole purpose behind this is if you take a outlook of autonomous operations and you go full autonomous operations, and that's where you start your mindset, we can lead to a situation where we put our operators, our people in production units at a high risk. There's always failures. We talk about, the comment was made that, with the car, you don't have the human anymore, so you don't have the human error factor. Well, guess what? All we do when we do automation is we take the human factor one step away, is what we do. There's still a human that's programming the automation. That human still can make a mistake. We see it all the time with, in the airline industry, you see it all the time with the autopilot. Sometimes it has to be taken over because there's a glitch. Something went wrong. It couldn't handle a situation. It wasn't, it was an abnormal situation that was not foreseen, and somebody has to manually take it over. So what happens on this airplane on your flight home, if that happens and there's nobody, somebody has to take over the plane manually, and there's nobody in the air traffic control tower that can actually remember how to exactly fly the plane, because he hadn't had to do it. He hadn't had to do it in 20 years. What happens to the plane? Well, hopefully your flight won't end up like the picture. Hopefully my flight won't end up like the picture. But we got to take a realistic look at what do we want to do with autonomous operations. And I don't use this example to come into to say stop doing it. It's the approach that we need to take. And I think it's kind of the approach, not kind of, it's the approach that we're looking into and what we're doing within BASF. So to give you a little bit about what I'm talking about is, I like to use the phrase right-sizing automation for our production units. So one of the first things for us that we need to understand as a team, automation team, is we need to understand where the business unit wants to go. What do they want to do? And then start to lay out a plan as to how we get there. What parts do we need to automate? So what is the risk versus reward? You're going to hear me say a lot about risk, because that is what we really need to be doing when we talk about removing people one level further back and back from actually our production units, which is a good thing. If you see up here on my slide, one of the first items, sub-bullets, is reducing exposure in related tasks. I think it's one of the key things we look at when we go into our plants is how can we reduce that risk factor? How can we take an operator and get him out of the way of harm? And so we look at that as an opportunity to basically automate something and get us one step closer. There's many things, there's many topics that you brought up, there's many topics that all of us need to bring up. We do want to minimize human error. We want to get rid of the human error in our production units. We want to look at opportunities to automate to increase quality. When you take away some of the human error, especially in our batch plants, you find that you are able to keep the quality at a higher level. That's why most of our batch plants are pretty much in cycles, and they run on good batch programs, because we want to keep the high quality. We can do further in that. And then the big key for us, I think, and we learned this lesson, we've done, I guess, I'm going to use the term again, although I don't like it, autonomous operations. We've done that at a couple of our sites across Europe. The one I'm most familiar with is Schwarzheide. And we've had a lot of success in that plant. And a lot of times, and the guy sitting in the third row in the middle, Mike Moody, always comes to me and he says, "Keith, what is your definition of autonomous operations?" And I say, basically, I think the same answer I'm going to give you is where our business units want us to take them in automation. That's really what it is. I don't have a firm definition from BASF to tell you that autonomous plants mean that there is nobody inside the fence line and everybody is away from the plant and somebody's controlling it in, at Starbucks around the corner. That's not what the definition is. The definition stays for me around what does that business unit want to do within BASF? Where do they want to get to and how do I get them there from an automation standpoint? The trend you had showed up there earlier was perfect. I mean, where do we end up landing? Do we ever land at the very top, fully autonomous operation? I don't know. We didn't get there with Schwarzsider, but I tell you what, we got a long way with that plant right now of reducing risk and increasing our quality, increasing our production rates and everything by doing what we did from an automation standpoint. I think we got to keep a key goal on there. So that process you see up here is kind of very general, but that really is what we follow. We basically sit down with our operations groups. We talk about where they want to be, what are the things that they want to try to achieve, and then we work it a piece at a time. So when I talk about the example in Schwarzsider, we started right at the base layer of control. Now that doesn't sound like autonomous operations, but that's where you have to start. You have to start, you got to clear up everything at the base level of control. Then you got to automate systems that are not automated. And then you start looking for advanced optimization of those automated sequences. So I think this is my last slide, if I remember right. This is how we look at the focus. This is the focus, at least our mindset is, and other companies may have different mindsets, and that's what I like being here for, because I can hear them and bring that to our team. But this is kind of what we focus on. We're focusing on safety and security. We want to avoid those unintended consequences. So in other words, I don't want to develop something fully automated and then end up with something that's programmed now that's going to end up being a glitch down the road, just like I talked about autopilot. So we want to avoid that. So we want to make that risk assessment. We want to do and make sure that we add in value and not increasing risk beyond the value add. We want to focus on the overall plant performance. I talked about it earlier, production rates and quality. So what does the business unit need to get? What is their goals as a business? Then we need to drive that when we automate things. How can we help them? Maybe the answer is no, we can't. There's nothing further we can do for you there until you do an expansion. That could be the answer. Could be further automation. We want to eliminate pain points. So you want to sit down with operators and you want to find out what pain points are. Starting up a unit, that might be a pain point. Man, we fight this thing tooth and nail. It takes us 8 hours to get the plant up and running stable. That may be something we can take out of his hands and do automation for. So those are the kind of things. And then last but not least, it's kind of a funny statement down there, but we want to focus on further automating the automation. So we want to start thinking about things like artificial intelligence. What can we do? You can have a driverless car, a pilotless plane. Why can't we have a section where we do a little section of the plant where we do some artificial intelligence and nobody really needs to touch it and monitor it? The one risk factor I'll leave you with that you always need to consider if you're doing a risk assessment, at least that's our viewpoint, is knowledge. Yes, we're losing our ability and our operators who have this knowledge base. We run chemical plants. We have to be very cognizant of the fact that we can't lose complete knowledge of the plant. Just like autopilot fails, it had a glitch. When we program and we automate, it can have a glitch. We all know that. And there's got to be people with the knowledge of what to do in that production unit should all automation fail. And it's not just the safety system. A lot of people I talk to say, well, that's why we got a SIS black box safety system. Can't be just that. We don't want to crash the plant every time we lose automation. We want to still be able to get production. We'll go out of business if we just say, all right, SIS is going to take us out every time. If we do that, we're going to kill our business units. So got to keep a focus on that. And the red arrow at the bottom is basically my message, I guess, in closing. Don't focus on fully autonomous operation. Focus on what you can do to further automate and continue doing that process until you get to the point like we had the success in Schwarzsider. It's not a plant that runs by itself, but I can tell you what, it has a lot less human interaction to make production. And that is it.
Well, good afternoon, everyone. We're really excited to be here. Happy to share our case study on utilizing AI to make the perfect Cheetos snack. Did anyone have any Cheetos today during lunch or snack time? Oh. So maybe next time, but at least you'll know more about it now, and we'll promise that by the end here. So I'm Max Petrie, and this is Anant Mishra. And again, we're going to tell you a little bit about the need for leading up to the potential autonomous operation within Cheetos, and we'll give you a little bit of details on how we're approaching it around the program. So a little bit more about us. So again, Max Petrie, Director of Applied AI, been with PepsiCo for 15 years in our global R&D foods team. At PepsiCo, R&D is accountable for product, process, equipment, and control specs of our supply chain facilities. So supply chain is more focused on execution once that stuff is there. We're accountable for developing technology, implementing it, commissioning it, et cetera. So within our Applied AI group, we've got two main charters. One is around the utilization of information for innovation purposes. So how do we get advantage innovation? How do we go faster, cheaper, et cetera? The other piece is around smart manufacturing and automation. How do we get better in our plants? And that part of our team is led by Anant. You want to introduce yourself real quick?
So I believe that the future is digitizing automation. Like exactly what he says, focus on automating automation. My responsibility in Pepsi is what is our vision for end-to-end automation? How are we going to deliver value? That's where I am focusing. Max is my boss. So I believe that that's the future of automation is going to be driven by shop floor, where IT/OT separation does not exist. That's the future of shop floor where we are driving, and that's the area where I'm focusing. Last 15 years, I have been in the space of automation engineering, and I joined Pepsi last May, but yes, I have been in the business of automation for a while to say that autonomy is the future for the future of manufacturing.
All right, and then we're also joined today by Dr. Jorge Morales, sitting in the second row. He is our foremost leading expert on food extrusion and our Cheetos processing across all of PepsiCo. So more as an end user, someone who's helping us build information into these tools as we're building them from the ground up. So really excited to have him here as well. He won't be on the panel, but we are around. We'll be at SeaWorld tonight, so happy to kick in some chat there as well. So first of all, a little bit leading up to the Project Excel. Cheetos, part of PepsiCo, obviously a huge global company. We're in more than 200 countries with over 300,000 employees across all these different regions. We're split into two separate groups. So we're in global beverages as well as global convenient foods. Obviously, Cheetos is a billion-dollar brand sitting in the global convenient foods section. We are focused specifically on foods for Anant, I, and Jorge. At PepsiCo, these actually are a little bit siloed. So to be honest, if you have any questions in the Q&A about what our beverage business is doing, we probably won't know the answer. So that's a place where they're kind of focusing on their own thing. They've got their own situation for how they bottle, et cetera. And then on the food side, we have a slightly different case. So for food specifically across North America, again, we have facilities all over the world. But North America, we've got about 30 facilities that we internally operate, and plus a few more co-manufacturers as well. And the challenge for us is across all these different locations in the United States, there's going to be varying water quality, varying ingredient quality, different vendors sourced from different areas. Over time, as we install new lines, the technology might be a little different. The setups are a little bit different. How do we continue to deliver high quality, consistent product between all these different locations? So that way, when you buy a Cheetos Puff in Seattle versus buying one here in Florida, that it's exactly what you expect it to be. It's the experience that you want as the consumer. So for Cheetos specifically, we have over 10 facilities in the US. So this certainly comes into play for us as we start to think about automation. So in my opinion, the opportunity for digital disruption is already here. So a lot of these challenges that we're going to talk about, I'm sure a lot of you are facing as well. So we're already facing things within the supply chain side of raw material disruptions. Things aren't delivering on time. We're not getting exactly the quality we're hoping for. We still got to go out and make the Cheetos that our consumers are expecting. Additionally, we're always getting challenged to be thinking about how can we increase capability to be able to deliver the same products with maybe slightly different raw materials. So wider spec range, just things that are a little bit different about them. Our processes are designed to do it a certain way, but now we're going to be asked to say, can you produce the same thing with something that's maybe a little cheaper, a little bit more variable? And then the last two more related to the supply chain facilities, Mark hit on this earlier. We're seeing high labor turnover in our operators and our frontline staff, just like a lot of you are in operations facilities. And we do have a lot of experts that are now retiring after 20, 30 years running some of these lines. So the average tenure of the people who are operating our core lines, especially in the Cheetos departments, is getting much lower. So the opportunity for technology to come in and help us consider how we're dealing with these challenges is right now. So how do we bring technology in, especially maybe in this autonomous space where we're increasing the equipment and the human capability to go operate these things in the field, knowing we're not going to have that tenure and expertise here in the near future. We still have to deliver high quality, consistent products as we've been talking about and while doing this. And especially as we're experiencing these disruptions, we still need to continue. When we're running, when we're up, we have to be producing at the highest rate and we have to be producing with the utmost efficiency. And that's also a play where we're looking to deploy these tools. So autonomous operations is something that's new for us in our manufacturing facilities that we're just now starting to get into. Advanced control is something that is not new. We've been doing like APC, et cetera, for a couple of decades now. We've also been looking at machine vision solutions since the early 2000s. These technologies are definitely getting more mature, which is making a lot more appetite across our organization to find other use cases for these types of things, which we'll talk about in a little bit. But especially from a digital transformation standpoint, we've, at PepsiCo, I've put a lot more emphasis into it over the past couple of years. That's part of the reason our team was formed, to go focus in these areas. And more recently, we've even formed a partnership with Microsoft as we look to deploy tools like Bonsai and AI machine learning to see how we can start to get the benefits for these things. So that's it leading up to it. Now let's do the fun part. Let's talk about Cheetos. How many of you feel like you've ever had a perfect Cheetos puff? Perfect. Okay, a couple. I mean, out of all the bags you've had, there had to be at least one, right? Had to be at least one. Okay. Okay. Ideally, you open the bag and they're all perfect, right? Doesn't matter where you are, anywhere across the country, across the world. But there you go. So the three categories when we talk to consumers about what makes up the perfect Cheeto tend to fall into these areas. One, it's the right shape. It's got the right length. It's got the right thickness, the right curl. It's a perfect 2, 3, or maybe even 1 bite, depending on how you go about eating Cheetos Puffs. It's got the experience you're looking for there from the shape and the feel. It's also the consumer preferred texture of what that is. So the bite, the crispness when you bite into it, the air structure, what we call the density and how it feels in your hand and when you're chewing on it. And then lastly, it's got the right amount of seasoning slurry as well as distributed evenly across the whole Cheeto. So it's not like one bite has none and one bite has all. It's like a big hit of salt and cheese. It's evenly distributed every time. So for us, this is the goal. Again, we want everyone to be like this, and this is going to be the perfect experience every time you pull out a Cheeto and open the bag. So before I turn over to Nat, just want to share a little bit about the extrusion process for those of you who are not familiar. So Cheetos is made using food extrusion. We take dry ingredients like cornmeal and water and put them into an extruder with rotating screws, high mechanical energy, high mechanical force, shearing those ingredients to the point at high temperature and pressure where it essentially turns into a liquid inside the extruder. It's then pressed through an opening or an orifice where it comes out of the extruder into atmospheric pressure and whatever the temperature is in the room. That rapid pressure change causes evaporation of the water in this process and is causing it to rapidly expand into these shapes, in this case of unseasoned Cheetos, which we call colettes. So our program today at this point is focused more on this front end around the extruder, but from there, then generally it would get dried, it would get seasoned, and then put into the package. In the long-term scenario, all these things are included as part of the future scope of bringing autonomous AI. So with that, I'm going to pass it over to Anant to tell you a little bit more about the program.
So I will walk you through a couple of challenges which we have, I will say, learned or at least managed to mitigate to a certain extent. We all know things which cannot be measured cannot be controlled, right? So we need to measure. And what are we trying to measure? We are trying to measure a very high volume throughput product. We are talking about thousands of pounds per hour moving in a conveyor system. It's a mobile system. We are not talking about measuring a stationary system. And we need to measure things which are supposed to be very accurate, right? Otherwise, there is no control. And if there is no control, no one is happy. So things which we wanted to focus was in a process, what really matters, what matters for operations, what matters for food scientists, and what matters for our consumer. All these three things has to be pinned down with process parameters which we feel needs to be digitized, because there are many data which we track, but most of the data are captured through operators, through process engineers who are on the shop floor. We can't control with very low fidelity of data sets. We wanted high throughput data. We ended up fixing the problem of what really matters in our process, how do we capture that, and how do we digitize it? Because if we digitize it, then only we can build custom applications on top of it. So the very first challenge which we wanted to tackle, are we able to capture the right process data? Do we believe it? And do we trust it? How do we ensure that we are tracking the parameters which we want and we are measuring in a way which quality guys agrees? So this is a topic which I can say that we have got a good hand on it. The point which I want to summarize, or at least the point which I feel the autonomous systems are built, or at least the requirement which it was, there is a subtle difference between automatic system and autonomous system, right? Autonomous system thrives on, I know a bit controversial, but real time or near real time, or at least real time to an extent where operator can take advantage of that data. That is something which we focused on, that we generate data which is consistent, which is accurate, which is accepted without challenge, but it should be near real time. It should be something where the degree of fidelity of acquisition should be higher than the fidelity of control which our users want. Just to keep it simple, I think we digitized it well enough. Once we tackle the problem, then we realize, okay, how do we control this, what we are measuring, right? We need to build a controller which is not existing in the world. It cannot be purchased off the shelf. It has to be built by process engineers, because we are trying to control a process, not a machine. And there is a subtle difference. We make an assumption that machines and process go hand in hand, but when it comes to food science, machine and process means very different things. So when we talk about process control and designing a process control, we had an approach of bringing multi-stakeholder tech audience to design the controller which they agree and they believe. Microsoft was one of our crucial partner, and it's not an easy journey. It's not a journey which took us months. It took us, I can say, good amount of months. So, and this is the a workflow which I think Microsoft can explain it exceedingly well. But the underlying technology of autonomy is coming from deep reinforcement learning. I know it's a mouthful of word, but deep reinforcement learning is being already used in gas turbine, a very high frequency operation. We also know, if you are following this, in Europe, nuclear fission reactors have already been controlled by deep reinforcement learning. Coal power plants are being controlled by deep reinforcement learning. Deep reinforcement learning has graduated from a kid to an adult. It has acquired its space in controls community. If you visit any of the robotics forum, you will see all the robot guys will be using one or the other way of AI-driven control, data-driven control. Deep reinforcement learning-driven control is one subset of data-driven control. We are taking advantage of what Bonsai as a low-code platform has offered and willing to help us and guide us to take advantage of the data which we are generating. The thing which we remain focused is where Mark started the story with trust. He started the story with that let's not add additional risk by bringing more automation. We speak in the language of tech plus business together. Robustness is for tech audience. Trustworthiness is for the people who trust the tech audience. We are taking very conscious steps that when we say the controller is ready, we have a very clear metric to demonstrate and calculate robustness. And we need to also bring right stakeholders in the room to really bring a good ecosystem of trustworthiness. This is not one after other. They both are working in tandem, at least in the project, the way we are driving it. Without this, I believe that we will always be a cool POC, but it is not something which will tackle the challenge number 3. We are interested in Pepsi to execute at scale. We are not executing this controller in a lab environment. We are executing in a classic brownfield setup. And this is a different level of game altogether. We all know production world is messy, but very optimistic. I believe that the production guys are the most optimistic guys in manufacturing business. We are tackling that problem of how do we execute head on. And this is a kind of a conceptual logical architecture I want to bring, but let's focus on the top 3 pillars where we are focusing. We believe that when we are talking about a scale, it is built on the foundation of connectivity and conversion. Without showing the real value of connection, or at least the maturity of connection, no one is going to believe the story of a scale. No plant maintenance people is going to believe that this solution or this POC is going to scale unless we talk about the elements which we have written in the connection pieces. It's not an easy journey. We all know a lot of words around like hard to Profibus to Modbus. Now we are hearing OPC UA. You might be also hearing next year with RabbitMQ when we talk about high frequency data set. Communication protocol is changing, and we know that it is not going to be stationary for next couple of years as well. We are keeping in mind that we are going to tackle this with sense of humility, that yes, it needs to be plug and play, but it will be under some constrained environment, plug and play model. We are always making sure that we take a step back and ask ourselves honestly, is it a future-proof solution? Or at least, are we closer to future-proofing it? Connectivity is a topic which tend to get into complex discussions, but we are making sure that when we are talking about future-proofing, we are bringing our security guys, we are bringing our IT guys on same level before we even go ahead and start investing more time and more resources in it. Connection is a theme where we are learning, I can say, and also discovering what is the right way to do connection for a typical brownfield setup. If you guys have any suggestion, please feel to enlighten us and educate us. We believe that we know how to connect, but we also know that there is no right way for brownfield. So every suggestion is welcome here. On the conversion, we are making sure that we don't lose our focus by focusing on the big story of autonomous operations, but keep focus on incremental value drivers, what we can offer to our plants today, so that they are cheerleaders of our journey, rather than kind of, okay, I don't care, but show me only if you are ready. So we are making sure that at every stage of project deliveries, and that's where you saw that we tackled our projects in different challenges. At each challenge, we are focusing what we can offer to our consumer, and the consumer, again, bringing it back, is operator, food scientist, and maintenance engineers. We are considering the persona of each 3 classes of user, and there is a value for each of the users when we speak autonomous in the language of their pain. And we focus pain and value go hand in hand when we remove autonomous from the buzzword and bring it, okay, what are we fixing for the operator who has to measure data every shift? Is it something a quality guy agrees towards? Is it something a maintenance engineer believes that he or she can maintain it? Or it is easy to be retrofitted, whatever we are building. So that is something which we are learning as we are discovering, but our goals are cast in a stone. We are going to build solutions which are ready to scale. We are not a POC team here. One word, if I want you to take away with this, is seamless interaction. That's our litmus test. If any solution which we are interacting, if it is not interacting either horizontal or in the vertical data stream, that's a proof that it is not future-proof. It's not something where we need to keep resources, investment. And it is something which might be a quick fix, but it is not a strategic tool set for us. So seamless interaction is the word which I request you to carry. And if you have any thoughts, please willing to share with us. So coming back to little tech kind of audience who is there in the room, we believe in the future of cloud. We know that shop floor loves cloud if it demonstrates that it is safe and if it demonstrates the right information is available to the right user whenever they need. So this architecture, what you are saying, is driven from the 3 user personas which I mentioned. In our use cases, we have time series data, we have event-driven data, which you might guess coming from quality. We have both sets of data coming into our process. We have legacy HMIs, we have legacy PLCs. Even in PLC, we have different classes of PLCs. And bringing your attention towards the unit op, we are tackling autonomy through unit operation, one unit operation at a time. We know there are trade-offs by following this approach, but we are right now in the zone where we say, let's bring things where the highest value for a given unit operation. We are trying to take advantage of all the new data which we are generating in form of digitalization of the process, or when we create new data out of the process, which is in addition of what PLCs are already recording. We are pushing the limit of showing the value of autonomy by building new soft sensors. And we believe that the soft sensor is the place where business takes maximum advantage of all the works which we are doing. And that is something which can keep adding the value over a period of time. So that's an area which we are doing. On the top side of the cloud, we are taking care of all the stakeholders coming from the IT community and also from the leadership who are interested on how does this solution helps us make ROI in a certain given time period. So the left side of the things are mostly related with people who are responsible for governance, people who are responsible for rolling out, and also the people who are going to be the owner of these solutions in the future. The right side of the team is mostly trying to tackle the people who are interested to take this data and invent Cheetos of 2025, or bring the plants at a level of efficiency which will be a big game changer for future. So we are taking all of these tackling head on. Unless we tackle this architecture and we deploy it, scaling is not real for us. We are deploying this architecture, and that is our story of how are we going to scale it and how we will make autonomous operation a reality for food manufacturing. With that, I request Max.
So just to wrap it up, I'll not hit on a lot of these things, but our 3 biggest things for you to take away. 1, don't overcomplicate it. Don't go for the full line all at once right off the bat. Again, focus on short-term wins. You can focus on individual unit operations to show that you can start to do some of this stuff in a plan, right? If you go for it all at once, it's going to take too long. You're going to lose your stakeholders. Focus on short-term wins. Number 2, continue to focus on the business. The technology is an enabler for the business, right? But without tying it back to ROI or something that your business stakeholders, the people who are funding and supporting you, can understand and measure, you may have some struggles. That's something that we've definitely learned along the way. And then lastly, consistent engagement with stakeholders, both governing your project, but also those end users. Our main goal is not to create something that's more complicated or too complex for our frontline operators to use or our lab technicians. They have to be able to integrate with it. It needs to make their lives easier. We need them as supporters. If it goes the other way, it might work for a little bit, but again, then you have a bunch of staff turnover, new people come in, you're toast. So staying close to your end users, absolutely critical. So with that, that's all we had. Again, hopefully next time you open a bag of Cheetos, you'll think about it a little bit differently. You might examine it a little bit. Your spouse or your friends might look at you a little weird, but we're used to that. So thank you for the time today.
While we're getting set up, I just want to give a little bit of context as to why Microsoft is on the stage in the first place, and also ask a couple questions. So I just want to see, just by show of hands, who's from kind of the IT side, if you could just show if you're an IT stakeholder, okay? And then who's from the OT side? Okay, so that's great to see. So just to give a little context, so my name is Jesse Allen. I'm one of our industry directors from Microsoft. And so I want to kind of broaden some of the best practices that we're going to share. We have a couple companies that are from the process manufacturing space, but autonomous operations can be applied in a lot of different ways. I personally worked on self-flying helicopters. It's a case study. You can look up the Bell helicopter. But even in supply chain, I worked with a glass manufacturer that asked us, how can I minimize moves in my warehouse when I take things off the factory floor and want to get them out the door? Because every time I touch it, we have increased risk. So I want to generalize kind of how you think about autonomous operations across your business, because there are a lot of use cases that we can share today. Thanks.
Space to speak. We can take advantage of not having 8 people up here.
So this is our panel session. Is anybody got a burning question they want to ask? Right there. Now what I want to do is get somebody up in the front corner here to ask the next question so that my colleague can run up. Now, go ahead, Tom.
Hey, thanks, guys. It was a really good presentation. My question is, and I'm not looking for any specific numbers or anything, but can you just talk a little bit about how much you were able to accomplish with existing technology, and then maybe a little bit about what your capital investments were like to get to these, make these strides, make this progress?
Yes, thank you. So I'd say, going back to first the investment question, for us, the only related capital is the ability to bring in instruments to be able to digitize this stuff. So bringing cameras or other things related to measuring the devices, and then the stuff on-prem that's being able to manage that, doing the modeling and simulation work that's helping us get calculations. So relatively speaking, in that case, for that specific unit operation, it's relatively cheap. Now, this is a POC at this point. Again, as you look to scale and you look to get to other portions of the line and other plants, other parts of the country, that number goes up, right? So we're not quite to that level yet, to be honest. So it's a place that we need to keep in mind, though, because again, as we start to look towards ROI, we're starting to get some peak on that. It may not make enough business sense for the whole organization to lean in if it's going to be a huge investment at every location. We know we're going to face hurdles that way, but definitely something we're keeping top of mind.
I'll say from our standpoint, and if you were here on Monday, you probably heard me say it if you were in one of the sessions with me. If you look at what you already have in technology, and we look across industry, roughly the number that people use is that we basically are using 60% of the functionality of what we already invested in. And it's why I emphasize the fact of starting at base layer. If you're going to get to the point where you're going to actually start spending some capital to do some things and actually look at AI and everything else, you better have your base layers working. And so, I would love to sit up here and tell you, we're great at BASF and we use 100% of every asset we ever buy. But the fact of the matter is, I don't think any company does. We we get fixated on shiny things, and we want to bring in the next shiny thing. But if you don't get that base layer going, I'm telling you, you're headed for failure as far as trying to get to, you know, that full autonomous operation.
Sorry, I'll add one more thing. There has been significant investment, at least on the software development side. So especially for us in deploying this autonomous controller for our processes, we've wanted the ability to be able to test the controllers that we're building with Bonsai digitally. So we want to know it's going to work, it's going to control appropriately before we put it on the line, where we can't afford to take any downtime today. We need 110% of all the capacity we have. So we have invested a good chunk of money in the 6 figures, low 7 figures, to be able to start to develop simulations of our processes. These will be redeployable for other use cases, no doubt about it. But it's been very important to us in utilizing these tools that we feel 100% confident when we go out to the line that it's going to work. And these simulators that we're building, data-driven simulators, obviously could be deployed in multiple ways, but that has required significant investment for us.
Brad?
So Brad Bonnet with Woods. So I'm going to throw a controversial observation out here. I appreciate the fact that both companies represented that we need to start with a problem statement and identify a problem that probably your operators already know exists. I've heard a lot of interesting commentary about how actually the executive level focus on digitalization and technology has diverted energy and effort and even funds from solving the problems that we actually already know exist because of the shiny object syndrome. Do you feel like we're finally beginning to emerge from that we're kind of normalizing? I'm beginning to hear some words, and ARC has helped with this to kind of begin to measure some of that normalization. But I've actually been in plants where managers, OT and IT managers have, well, we had a plan, we'd identified problems, and then they got redirected because of a redirection of focus. So any feel on that, or do you feel that we're actually empowering the right things being done? And that will vary company to company, I know, but I want to kind of throw that out because that's something that I heard that I appreciate, because telling our people they don't know how to run the plant, that's not going to work, but finding the problems that they're having problems solving, and can we go find the right tools to solve them, that's a rational approach.
No. Okay, I'm going to address one topic, and I think it's in alignment with what your question is from sharing. Yes, we left the field of trying to go find pain points and try to find what our areas of improvement could be from an automation standpoint, and went into this catchphrase of digitalization. Okay, no doubt about it, and the focus went in the complete wrong direction. All right, it's no doubt about it. It's really time for industry as a whole, my company, all companies, to basically sit back and now say, all right, that was fun. We spent a lot of capital money. It was fun. We didn't get value. It's time to take it and say, I'm going to take the IT approach out of OT. I'm going to remove it, because that mindset does not work on a production floor. At least I can tell you it doesn't work for a production floor in a chemical facility. We got to go back to finding the problem and resolving it. And we can do a lot with that. We've done that now in BASF. We kind of started, you asked about turning the curve. Well, we actually started doing that. Some of what we've implemented now in Europe for our BASF has been very, very valuable to the business units. We're actually focusing on what the problems are, and we're fixing it. And as the gentleman in the back said, when we start looking at this and we start looking at the problems again, then you take your base layers and you start improving upon it, and you build that automation. And then you gradually bring that up. And that's exactly what we did in our plants between Antwerp, our plant in Switzerland, and Schwarzheide. That's exactly what we did. We started listening to exactly what the pain points are.
I do have just kind of a funny story on that point from the other side. So I worked with a CIO, and he said, I want to solve a problem using AI. So we brought in a company, and they said, we're looking at your OEE, and we can make a 10% improvement, but it's just using statistical process improvement. And he's like, I'm not interested because my CEO told me I have to solve it using AI, right? So to your point, we did start there a few years ago, and companies like Microsoft realized this. And so we were always focused on selling to IT, and we realized, hey, it just doesn't work. They don't understand the factory floor, both the methodology and the problems, right? So my team and one of my peers in the audience, our team was actually formed because of this issue, because we kept getting into this POC purgatory, right? Where you would start a project, everybody's excited, you're checking all the boxes, and then you get to the factory floor and they're like, I can't use this. How am I supposed to implement this, right? So I think you're absolutely right, where now, we start with engineers that worked on the factory floor. We work with plant managers, and we say, we won't meet with you until you can get a plant manager into the meeting with you if you're a CIO. And then we start with the matrix to say, okay, let's look at impact and cost and risk, and let's kind of map out the projects together, because if we don't do it that way, we'll just get to a certain point and hit a brick wall.
Yes. I can just chime on that. I think for anything to stick around, there has to be some courageous leadership. Someone has to put their skin in the game. No doubt about it. If courage is missing, no change will ever happen. But at least in Pepsi, what we have seen is a very clear, courageous leadership. Like, people believe it because they see a value. They trust the people that value will be generated. And when we are executing, we are not in lab. We go to shop floor. We sit in shop floor. And in shop floor, you don't get things done unless you don't listen. It's period. So unless we bring all the user stories together and we tie up before we even bring technology, I think it's that the nervousness comes in implementation because we feel we have not heard enough. But if as a developer, if we feel that we have heard enough and we are taking all those opinions in true consideration, not just for the sake of slides, I think people come along very easily because result speaks. So courage comes when we take everyone along and we listen with an intent to act, not just to keep the other person happy.
Mike?
Yeah, so Mike Moody with BASF. And so this, just kind of looking, first of all, taking your takeaways of, don't go too big too fast, right? And the unit operations approach. If you look at it from where are we today, what is my plant as is, and where do I want it to be at some point in the future, you're going to see a gap, right? And then if you break that gap down into different aspects, you can start addressing those. And like Keith mentioned, it matters how far you get over time. You have to be competitive. But the key is that you're making progress. And if you try to go too big, you might not make any progress for a long time. So maybe take the easy wins. But I was going to get your impression of this. I was talking with somebody at lunch, and they mentioned if we layer some of these tools and things on top without getting the base correct, sometimes what we do is we hide problems that are there. And even though it makes things better, we never ever get to where we want to be because all we did was kind of cover something up, put enough mattresses that you didn't feel the lump, right? But it's still there. And so are y'all looking at it from that aspect, or?
We have three golden words here. We don't get that the work is done unless we have clearly articulated the game rules of who is going to operate, who is going to maintain, who is going to retrofit future versions. Unless we have figured that out, work is not done. So operate, maintain, retrofit are the three golden words we have heard in very clear terms from our controls team, our operations team, our quality team. Work is not done unless we have a clear answer for each of the three. Otherwise it's POC. Did I answer you?
So, can you hear me? Okay.
Yeah.
I think all the conversation really resonate with me. ExxonMobil, focus on the value and, really be cognizant of the total cost of ownership of the technology and focus on the base engineering control. Where I am is more, I just came out of another conversation, focus on human-centric versus autonomous AI. I just want to pose the question here is more, okay, let's say, Keith, we address all the base control issue. Let's say we actually do have the, like a cost curve to actually get there. I think there's a very good question about, because AI or the data science, there's always an element of unpredictability. It's not entirely predictable. It's a nonlinear process. So the question is, do we really want to go after autonomous operation? Or we really want to go after augment our, workforce to become more capable and become more productive as the end game? So that's just a question. I just want to try to get your perspective on that.
I'll pay you for that question a little later, buy a drink. Yeah, I think, and I'm going to use another airline example that actually happened to me. And it kind of, I think, is going to kind of direct what my thought process is on this, because I talked about knowledge a little bit and keeping knowledge in our plants, in our workers. And the reason I say that is I sat on the tarmac, I actually sat at the gate at Houston Airport, Terminal B, for roughly 2 hours, because they have a completely automated system now for balancing weights of luggage to put on the plane, across the plane. Well, the automated system didn't work. And nobody that was at the airport that day working knew how to do it the old way. So we had to sit there at the gate for almost 2 hours as they call somebody out and drive in and come out there and show the team that was out there how to do that. Now, if that guy retired, I don't know how much longer we would have been sitting out there. So there's an aspect that we have to understand. That's why I talked about going fully autonomous operations. Yes, it's a great dream, and we want to head toward that target. But where do we land has to involve our people. It has to involve knowledge transfer into our people on why things are the way they are, why they're automated that way. We can't just automate and say, okay, y'all fired, go home. We don't need you anymore. You have to have a knowledge base. So we have to invest in both. It has to be invested in people.
Completely agree with Keith. This is not going to replace. We're not going to put people out there who we're not training to be on the floor. They're still going to have to go through that same level of understanding. And we should be open with how we're building it, some of the things that are there, so that when they see it make decisions, that they can understand what happened. But I think in that case, there still is a reason we want to push forward. To Keith's point, we're not going to replace our operators. Our operators still play a critical role. We can design our AI to manage, call it 80 or 90% of what's happening, but there's still those random events that are going to happen that we're not going to have a sensor there to figure out what's going on. You're going to need a physical person that understands it. It can go ahead and make those adjustments. But for that other 80 or 90%, as we talked about, we've got people that have been there 3 decades running these lines. We have pretty good visibility already that these AI systems are really good. So I think our first test that we did on our Cheetos process, we intentionally put it out of range, and within 12 minutes, it made 2 simultaneous adjustments, and bam, it was already right at the center. First time we tried it. As someone who's run these things for 7 or 8 years, again, Jorge wasn't there, so maybe he would have been able to outdo what I was thinking. But I looked at that graph, I was like, what? I was shocked that it made those 2 simultaneous adjustments, because it was already calculating what the first one was going to do and accounting for it. So needing that capability to step up for the challenges we're going to face in the future, that's where these tools can really help us. It may not work 100% of the time, but I have no doubt that the variation within our capability today is going to get much tighter, and it's going to enable us to do things that we can't do today, even with the best people.
And to add to what you're saying, I think that the difference a little bit now is the methods and how we're training those people, because they need to understand how that augmented reality, how that is actually working so that they have a better understanding of why something happens. And so it's a different type of training we got to instill in our people on the shop floor. So,
Perfect. Yeah, and if I could just add to that, so that graph that you showed or the slide about the levels of autonomy, I was just thinking about my customers and how we interact. And one of the exercises I would do as a leadership team is to say, you know, what's the value going from level 1 to level 2? Forget about 1 to 5. You know, there's a lot of value 1 to 2, 2 to 3, 3 to 4. You know, to your point, going to 5 might never make sense, or the investment to get to 5 might never make sense from an ROI perspective. But you can get an awful lot of value going from 1 to 2. So that's how I would think about it.
I think, if I may, because I'm the panelist,
You are
I'm
the
in charge.
facilitator.
One of the things, if you look back in time and you look at how we've got to where we're at, we've slowly built on our automation, right? And technology has improved, and we still built on it. And I think what we're watching is we're building upon what we've already made. What we're going to see is we're going to continue that trend. And you're not going to get there tomorrow. You're not going to get there next year, but we're going to start seeing over the next 10 years, we're going to start seeing some very strong cases for autonomy because we've incrementally improved. And that jump from 1 to 5 is really a jump from 4.5 to 4.7 to 4.8. So I'm a little bullish on it, obviously, but that's, yes, sir. You, yeah. You
I'm Jan, I'm with BASF from Germany.
He's also my boss.
It resonates a lot in me, also your question. Yeah? And we are talking since decades for now about autonomous plants. Yeah? But I would say also the parameters of the environment had changed. Yeah? So therefore, in the past, we talked about due to reduce the costs due to labor. Yeah? At the moment, we have the driver that we do not get the people to run the plant 24/7. So therefore, we need to be, on the one hand, be prepared that we need to, I would say, to automate more, to be ready that we get less people, but we need also then to see how we can skill them up to the level that we need them. Yeah? So I would say the environment is changing, but I'm fully with Keith that we need to implement the tools that we are having. They are highly developed, and also in Schwarzheide, we saw that we implemented controller performance monitoring, alarm management to a higher degree as it was established, and it helped the plant a lot. So it means also we need really to drive that these technologies are really deployed and also in use. Yeah? And then coming then to the next level is also not to consider, just to consider the technologies that we need to deploy. It's also what does it has impact on the skills, but also on the regime, how you run a plant. Yeah, so therefore, this is also what we are discussing internally to come to a higher level there. But at the end, I would say you need to find for your plant and for your environment, your solution and the way to go there. So, and this is not one fits all. I would say it's a journey you have to follow. You see that also with Pepsi. They have also some solutions in place, but I'm fully with you, Keith. We need to bring the basics in place and run it as best as possible, and then we come to a higher level.
I've got an extra chair up here if you want to sit up.
Is there any chance that I can get a copy of that video right after this? I just had my boss tell me he agreed with me twice, and I would just like to get a copy of the video.
I can just add. I can just add. Have a look into IEC 61131. I know I think you are concerned that how come AI is treated like a classic control system, right? I think you mentioned one line which I think we discuss a lot in our team, that the uncertainties which are built in the model, how are we tackling it, right? I think, I don't know, everyone has to figure out their own way of tackling it. The best part is at least the AI community is accepting that the robustness as a parameter has to be structured. IEC has taken a first stand. At least IEC community has came up with a standard. We have a couple of booths talking about 61131 compliance. But in the chemical industry, at least the American Society of Chemical Engineering is also talking about how are we going to build control system certifications. Robustness is a work in progress. All the community who are working in uncertainty quantification has been taking advantage of this. We know all our MPC community has already tackled it. So it's not like we are in unwatered territory. It's just replacing the mentality of model-based system engineering to data-driven system engineering. We are not changing the boundary conditions of it. So it's a hope, it's a wish list, but I think the proof of the cake is in eating it. So we will see how it works.
That's a good point.
But,
That's a good point.
Just to wrap that up, one way that I guess a rephrasing of autonomous plants that I see my customers taking now is it's not about autonomous plants, it's about making a worker on his first day as productive as my best worker, right? So using AI to improve productivity of the workforce and improve quality at the end versus trying to cut people out of the loop.
Yeah. That's a good point.
Have we got any others? Anybody else want to ask a question? If not, I'm going to thank the panel. Oh, you want to do it?
It's not just a comment on the board. So you guys were trying to make the perfect Cheeto. So now this goes back years when I was in college taking a class on artificial intelligence, and it was one of the most complicated books I ever read, so I decided I didn't want to do that. But anyway, one of the stories that the professor was talking about was Campbell Soup wants to make the perfect cans of soup, right? And they were struggling, and their quality had just taken a dive. And they brought in a consultant and said, what's changed? So, well, we did have somebody retire. They said, well, let's interview him. So they went and interviewed the guy, and then they talked him into coming back to the plant. He said, well, if it's kind of cold outside, I kind of go with just this and that. And if it's humid, I'll go do this and that. And he just had all these things he had learned over 30 years of operating that he would tweak based on environmental conditions outside and in the building. And so then they built like an expert model base and just kind of built a database of all these things, just kind of extracted it from me, built a system, and where they could tie the information directly in or input it, it automatically made those corrections. And someone had mentioned in one of the earlier sessions about we have to take that knowledge base, and it's not in the worker who can leave, but we got to put it in the systems that stay put at our plants. And I think that's going to be a big part of this journey is getting that information into these systems. So,
Well, Mike, to that point, what you had said earlier, and that really kind of resonated with me because he made the statement that you can't control what you're not sensing. But when you get that knowledge base, then you get those sensors put in place that you can control off of it. So that is key. You got to identify what pieces of sensor data is not there. And that's just a learning curve as we go along trying to do these things. Is you gotta figure that out, and you gotta figure out that way. I mean, hopefully, if you got to bring a retired person back in, they say no. But I mean, that's what you got to.
I hope, yeah. Just one correction: we are making perfect Cheetos for you.
Yeah.
So
I've never been a Cheeto I didn't like.
Me either.
I just want to add that I'm actually coming from the data science and the AI part of the group. I really like what Jesse actually landed on. I was more trying to advocate. So we need to automate. We're gonna relentlessly automate, just like for sustainability basis and for the future workforce. No question about that. I think what I'm trying to get to is maybe we can reframe, how we think about the future operation. Instead of calling autonomous operation, we continue to call it, automation. And it's a purpose-driven automation. Because as we start to talk about autonomous, we may actually there's a connotation that you're gonna take the human out of the loop. I don't think we're ever gonna take the human out of the loop.
Right, it's perfect.
That's well said. I mean, that is perfectly said. I mean, I think I like the concept of getting rid of buzzwords because it comes with a connotation. So, effective today, no more autonomous operations.
Jesse's like, oh.
Furthering automation. This session is now called Furthering Automation.
So to that end, just to amplify that point, we've taken an approach which is you start with a co-pilot, which is, hey, what does your best engineer do, right? And you try to mirror and codify as much of that behavior as you possibly can in software. So you start with a co-pilot, and then what you can start to do is say, well, parts of what this person is doing is pattern recognition, right? And workflow automation, right? If this, then that. If we see the temperature go up in the plant to this, I'm going to make these adjustments. Well, what's nice about AI is you can start to use that for pattern matching. So you go from a co-pilot to an autopilot. Still informed. I've taught something in the co-pilot, and now this autopilot starts to learn. And once you have enough autopilots, then you can start to talk about autonomous operations in certain roads, even though we're not going to talk about it anymore. but the steps to that are a lot less scary, and they get people comfortable with the fact that there's a real sense of engagement and actually agency. So we'll name co-pilots after people because you know what? If Jane is the absolute best at this particular part of the process, then by gosh, she wants credit for it. And you start to work through those steps, and it becomes a lot less scary and a lot more acceptable. And all of a sudden, we start to get to these types of gains.
Okay, last one.
Just one last, Jitendra Kadam, ExxonMobil. So I'm in this area of autonomous operation. Actually, we use the autonomous operation as a North Star direction, but our real goal is intelligent, self-optimizing plant. Make more money, be more efficient. Eventually, we will get there. But I think internally, we talk about self-optimizing plant.
All right. Okay, so with that, we're going to end the panel. Thank you guys so much.